Now let's come to the main stuff. How do we scale the various components of our platform to billions of users? First, let's think around scaling the video uploading part. Let's say we have a dedicated video upload service with which the user calls the upload video API via the web backend. Now, video uploading could take a very long time to process and store. So we wouldn't want the user to keep waiting on the screen while our backend processes the video. So perhaps we can think about making the process asynchronous. We can asynchronously publish the content of the video in a Kafka queue. Since we want to process the video in smaller chunks, we can have a dedicated file chunking service which batches the file in smaller chunks and further processes it. As this service keeps processing, it needs to communicate the status and completion rate to the user, so it can interact with a notification service which does this. Now, a video chunk also needs to be stored in multiple resolutions, and we could also compress it to optimize storage. So for these purposes, we can also have an encoding service which takes care of this. After that, we need to store the video in the file system so the viewers can retrieve it later. We're going to be storing millions of videos over the years, so it's really important to partition these videos in an efficient way. If we store all the videos in a single directory, the retrieval would get inefficient as it would have to scan the names of all the video files. So let's think what should be the first level of partition. If you live in US, it is very likely that the viewers of that video will be mostly from US as well. So perhaps the first level of partition we can do is by country name. Each country will have a different folder under which further partitions and videos will be stored. The next partition we could do is by finding hash of the video ID. So all the videos with same hash outputs will be under the same directory. This could further lead to imbalance of the sizes, so we can combine consistent hashing with this. Inside these folders, we can partition the video with folder name as its ID itself. Since one video can have multiple formats and resolutions, we can further structure the different chunks based on different formats. After this, we finally stored up chunks inside the folder in a sequentially sortable manner. Now let's look at how we can scale the streaming service. Since a viewer will keep receiving chunks of video, we can keep a dedicated WebSocket open between him and the streaming service to retrieve the chunks. The communication will be done via a gateway. The gateway will be responsible to retrieve chunks from the watch service via the stream video API and the chunk offset. The watch service will be responsible to retrieve file chunks in a sequential way. Since we used file chunk service to encode the videos, we'll need it to decode and decompress as well. The chunk service will directly pull chunks from the file storage. Now, if a video goes viral, we don't need every viewer to retrieve the chunks from the file storage. So when a chunk is being pulled, we'll store it in CDN as well for faster retrieval next time. Depending on where are the viewers of the video located, we'll push the video to global or their local CDNs. An example of this process is if you open any video and go to the Networks tab in the inspector, you'll see multiple chunks being continuously retrieved from the network one after another. If you see result of a chunk, you'll see the binary decoded stream of the video which is being rendered off the platform. Finally, let's have a look at the video searching service. Since we've designed this in-depth in Google's system design, we'll only be overviewing it here. A user sends his query to the application servers via the web. Since the distributed try store could persist on different servers, we'll have a dedicated aggregation server which will aggregate all the results and return them. This aggregation could be done in various ways like relevance, trends, or personal preferences. The search results will be retrieved from multiple search service servers. Each server will query from its own database to find the indexes of the search query and retrieve it back to the aggregation service. Since a lot of viewers could be searching for a similar query, we can push the trending query results onto global or local CDNs for faster retrieval next time.